Okay, now having learnt all the skills, we need to start to apply them to certain scenarios where we might be asked to show things or prove things are true. So we're going to start off with collinear points. Now what collinear points mean is that the points are on the same line. So if I look at this pictorially, I've got a line and I've got this point, and this point. They are collinear. This point over here, he's not, all right? So these guys are collinear because they're on the same line. So we need to think about how we could prove, given 2 or 3 points, given 3 points, how can we prove that they're all on the same line? So let's have a look. If we've got so we could have on the same line or collinear. Oops, collinear. All right, let's think about it then. If they're on the same line, what is true about it? Well, looking at that picture, that means they're all on the equation of a line. So we could find the equation of the line of 2 of the points, right? We can use the gradient method and we can use the equation of the line. And then we can put the other point in as a substitution and see if it is on the line. That would be one way of doing it. So that would say, find this line, now put this point into it and find out if it's on it. What other way could we do it though? There might be a faster way. Anybody, any ideas? What do we know how, it's got nothing to do with length, right? It's got nothing to do with midpoints, so therefore it's got to be to do with some of the other things we've learned. What's the gradient of this line? Who knows? Let's say it's m. So what's the gradient of this line? Well, it's the same line, so it still has to be m, right? So if that gradient for those two is m and that gradient for those two is m, does it mean they're the same line? No, they could be parallel, you're right. So how can we prove they're not parallel? Well, we don't have to prove it because that point was on both of them. So they're not on different lines. This line with that point, this line with that point. So as long as we've used a point in common, we can prove from three coordinates that we have them on the same line. So let's have a look at this one and do it both ways. So the gradient for the first 2 points, let's call them A and B and C. If we like A's and B's and C's. In maths, we like X's and Y's and things too. All right, A, B, and C. So let's look at the gradient of AB. That little thing there means the line AB. It equals y2 minus y1, so y2 minus y1, 2 minus 5 over x2 minus x1, 1 minus 2. So that equals negative 3 over negative 1, or 3. Okay? Let's find the gradient of BC. So that equals negative 4 minus 2 over negative 1 minus 1. That equals negative 6 over negative 2. That equals 3. Tick. Common gradients, and they both have B. So we would write that. They have the same gradient and B in common, therefore they're collinear. All right, doing it the other way, finding the equation of the line and substituting, same method. So we've got this, we're going to find the equation of AB because we've already found the gradient. So we'll use A. So we've got y minus y1 equals mx minus x1. So y1 is 5, y minus 5, gradient is 3, x minus 2. So y equals 3x minus 6 plus 5. So the equation of this line is 3x minus 1. So remember I said that we want to prove it by putting the other point in. So we take, substituting c, we're going to get negative 4 is equal to 3 times negative 1 minus 1 is equal to negative 3 minus 1 is negative 4. So yes, they are equal. Therefore, that point is on that line, and so were the other two because we used them to find it. All right, so a bit of practice on that.